Hello, year 9. Um, Today's lesson is on group 7, the halogens. If you can make a start on the questions you can see right now. When it's time, we'll continue. Thank you. Still got about 3 minutes. 3 minutes to go. Thank you. Got about 30 seconds, 30 seconds to get through the questions. Thank you, time up. So the first question is, why is oxygen positioned in group 6 of the periodic table? I'll go straight to the mass scheme so that we can get on with the work. So if you look on screen, currently the answers are provided for you. Group 6 because there are 6 electrons in the outer shell or energy level. Again, if you write down the electronic configuration of oxygen, it shouldn't be carbon, it should be oxygen, sorry. So that is 2,6 for oxygen. I'll correct that for the main video. So number 2, why do group 1 elements have similar chemical and physical properties? The simple is because they all have one, group 1 elements have one electron in their outer shell or energy level. So the third question was about why alkaline metals were reactive. Remember the examiner said you could score 2 marks. So that gives you a hint as to which answers you should write down. So first of all, you need to tell the examiner that there's one electron in their outer shell or energy level, and it is very easy to lose this one electron when they react. It's very, very important that you put the word easy, okay? Easy to lose, because it's talking about why they are reactive. And the challenge this time was just 1 marker. The reason I put this challenge in is most of you will not have done bonding or structures. So I was hoping that whoever will be able to do it had read ahead. So it's talking about the fact that when group 1 elements react with water, hydrogen gas is released and a solution is formed that contains a metal hydroxide. What is the structure of hydrogen gas? Again, hydrogen gas exists as a molecule. Hydrogen gas exists as a molecule, and that is why the answer is a small molecule. Hydrogen is a small molecule. When we come to do bonding and structures, we'll get to understand what we mean by small molecule and large molecules. So that is why the answer was small molecule. Again, a molecule normally have covalent bonding. Okay, molecule normally have covalent bonding in them. In other words, electrons are shared. Electrons are shared. Again, you have this available to you on VLE, live VLE, latest by Monday. So if I go too fast and you're unable to write down all your answers, I don't want you to panic, because if you go live on VLE on Monday, you can make sure that what you didn't finish, you can finish up. So go about 20 seconds and I'll move on. Those who are still writing. Thank you. So we start the whole lesson. Key vocabulary or keywords for today is group 7, halogen, halides, reactivity, boiling point, and force of attraction. Again, the learning objective, I didn't edit this PowerPoint, I'm very sorry about it. So the learning objective is to understand physical and chemical properties of group 7, not group 0, group 7. Our learning outcome is to explain how properties of the elements in group 7 depend on the outer shell of electrons. Describe the nature of compounds formed when chlorine, bromine, and iodine react with metals and non-metals, and predict properties from given trends down the group. Let me just apologize again. The learning objective is to understand the physical and chemical properties of group 7, not group 0 as it appears on the screen. So I want us to go through this. So point 1, on the left-hand side, on the left-hand side, you can see the electronic structure of halogens. That's fluorine, chlorine, bromine, and iodine. So these are the halogens that we are supposed to know and we are supposed to learn about at GCSE: fluorine, chlorine, bromine, and iodine. So the first point is the main elements of group 7 are fluorine, chlorine, bromine, and iodine. The second point is that group 7 elements are also called halogens. Why the name halogen? The name halogen came from a salt former, because halogens react with metals to form salts. Okay, so halogens will react with metals to form salts. And the word halogen means a salt former. The third point is all halogens have similar chemical and physical properties. Again, just as we know about group 0 and group 1. Okay, so for halogens, the reason why they have similar chemical and physical properties is because they all have 7 electrons in their outer shell or energy level. If I take you back with what Dr. Thompson did with you when she did group 1, she talked about the fact that group 1 elements have the same physical and chemical properties or similar physical and chemical properties. Why? Because they have 1 electron in the outer shell. So group 7, the same thing, they have 7 electrons in the outer shell. The fourth point is halogens are reactive. Halogens are reactive. The question is, why are they reactive? It's very simple, because they only need, the keyword is they only need to gain 1 electron, okay, to become noble gas configuration, or to gain what we call as the noble gas electron structure. So the word configuration and structure can be used interchangeably. So if I put configuration, don't get confused, it's the same as structure. So the reason why they are reactive is what I've just said. Another point comes up. Halogens are non-metals. So again, when Dr. Thompson did the modern periodic table with you, you did realize that she did talk about the fact that there are 8 groups in the periodic table. Group 7 has 7 electrons in the outer shell. She talked about metals, she talked about non-metals. So group 7 elements, which are halogens, are also non-metals. Again, particles in each of the elements are molecules. In chemistry, we use particles loosely, so we can use the word particles to represent molecules, to represent everything that we want it to represent. So particles in each element are molecules that contain 2 atoms. 2 atoms, therefore we say it's diatomic molecule. 2 means di. 1 means mono, 3 means tri, 4 means tetra. These molecules contain 2 atoms, and therefore we say they are diatomic. Example is F2, Cl2, Br2, and I2. Remember that the 2 in there is a subscript. Don't write this as a big 2 in front of the symbol of the element. It should be a subscript in front of the symbol of the element. Number 6, the relative molecular mass, melting point, and boiling point increases as you go down the group. I'll be talking more about the melting and boiling points later on, so I don't want you to panic at this stage. So the relative molecular mass, melting point, and boiling point increase as you go down the group. I'll be giving you reasons later on in the lesson. How do they appear, and what is the state of our halogens, or the halogens that we are aware of at room temperature? So again, in chemistry, most of the things we say, so for example, we would tell you, oh, water is a liquid. If somebody tells you water is a liquid, it's because at room temperature, water is represented as liquid. So again, we are looking at this in terms of room temperature. So fluorine and chlorine are gas, or they are gaseous. They have a gaseous state, or they are in a gas state at room temperature. Bromine is a liquid at room temperature. Iodine is solid at room temperature. In other words, if I bring chlorine to the classroom or to the laboratory and I put it on the table, because we are in a room, the temperature in there is referred to as the room temperature. So the state in which chlorine will be, or fluorine will be, when I bring it to the laboratory, will be a gas. Bromine will be a liquid. You may have seen this, your science teacher may have shown this to you in the past. Iodine is always a solid at room temperature. Astatine is a radioactive element. So these are some of the properties of halogens. Number one, if you look on the left-hand side, I'm looking at what I'm considering. The right-hand side of the table describes its properties. So the first one is, are they metals or non-metals? The right-hand side gives you the answer. So it's a non-metal. So all halogens are non-metals. Number two, they are very toxic. Very, very toxic. All halogens are toxic. Number three, in general, their melting and boiling points are low. They are very, very low. However, the melting and boiling point will increase as you go down the group. Why? Because the molecules get bigger or heavier as you go down the group. I'll come back to that point, so I don't want you to panic at this stage. Number four, how did they react with non-metals? They react with non-metals by sharing electrons to form molecules, to form compounds, made of molecules. Number five, how did they react with metals? They react by easily transferring electrons from the metal to the halogen to form compounds made of ions. So they form ionic compounds. So the halogen always forms one minus ion because they need to gain one more electron. Because the electron is negative, if you gain one electron, you become negatively charged. So halogens always form one negative ions. That's what I mean. So for example, Cl negative. So you can see the negative at the top here. If I surround it with my cursor, go around it. So you can see the negative there. That telling us that halogens form one negative ions. Why do they do this? Just to make sure that they become stable. Okay, to get what we call as the noble gas electron structure. Same as halogens wanting to become stable. So talking about noble gas electron structure, that's what I mean. Now this is what AQA says we should also look at. How do we predict properties from given trends? So I've given two main key points here, and I'll go on to explain it further. So number one, melting and boiling point increase down the group. I've mentioned it earlier. Reactivity decreases down the group. So this is something new I'm mentioning. Let us have a look at the melting and boiling points and what causes it to increase down the group. So again, I've got a bit of stuff on the board if you have a look carefully. So on the left-hand side, I've got a graph. Below the graph, I've got the electron structures of the halogens that I'm considering. On the right-hand side, I've got something written about the graph. So I want us to look at the graph, and then we'll come back to the written one later on. Probably it's for you to read. So we did talk about the fact that in general, halogens have low melting and boiling points. It is a typical property of all non-metals. Every non-metal has low melting and boiling points. Fluorine has the lowest melting point and boiling point. So if you look at the graph very carefully, fluorine's melting point is around -222. Look at the graph carefully. If you look at its boiling point is around -175. So you can see that of fluorine. If you look at that of fluorine, it will tell you exactly what it is. You can see how low it is, very, very low. But as you move down from fluorine to chlorine, you can see the boiling and melting point is beginning to increase. Bromine, iodine then goes into the positive. Astatine also goes into the positive. So you can see melting and boiling points are increasing down the group. Why does this happen? Number one, because if you look at it carefully, now I will take you to the electron structure here. Look below the graph, you see the electron structure. I am going to put some arrows on it right now to be able to explain to you what I mean. So you can see I've put some light blue arrows on each one of them. So fluorine has got the arrow, chlorine, bromine, iodine. I am using these arrows to represent the size of each of these elements or atoms. So fluorine, you can see, has the smallest size. Look at the size of the arrow from the nucleus to the outer shell. Chlorine followed by chlorine, from the nucleus to the outer shell, from the nucleus to the outer shell. So from this electron structure, you realize that the size of the halogens increase as you go down the group. So that's the key thing here. Number two, the molecules, when you take a molecule of a halogen, they have what we call as a force of attraction. We normally refer to as the intermolecular force of attraction. So there's a force of attraction between the molecules. This force of attraction increases as the size of the halogen also increases. In other words, as the halogen molecule becomes bigger, the force of attraction between them also becomes bigger. So when the force of attraction becomes stronger, not bigger, becomes stronger, it means that just to be able to overcome these forces, you need a lot of energy. So these are key things. Number one, size of the halogen as you go down the group will increase. Number two, because the size increases, the force of attraction between the molecules also becomes stronger. If the force of attraction becomes stronger, it means you need more energy just to overcome these forces of attraction. Because if you are going to melt it, what you are going to do is to separate the molecules. You are going to separate the molecules. That's what it means by melting a substance. So the melting and boiling point increases. Let's take a look at another thing. Again, I've used the same blue arrows here to indicate the size or atomic radii of group 7 elements. Again, if you look at this carefully, I brought this up with the arrow telling you that the reactivity decreases as you go down the group. So the examiner normally asks, describe the trend in group 7's reactivity. And the examiner will put 1 mark. You need to just talk about the trend. And the trend means you just write down in group 7, the reactivity of the elements decrease going down the group. The reactivity of the elements decrease going down the group. This means that fluorine becomes the most reactive halogen, because if it's decreasing down the group, then it means that the most reactive one will be fluorine and the least reactive one will be iodine. Now the question is, how do we explain this trend? Because here we can see that size is increasing, reactivity is decreasing. So the reactivity is decreasing. How do we explain this trend in reactivity? I've got a lot of things written here. I don't want you to panic too much. I'm going to use the diagram at the top to explain, and then I'll refer to what I've written below it on. So I've got X. You can see the letter X here. This letter X refers to the incoming electron or the electron to be gained. So this is the electron that the halogen is looking at gaining to become stable. Remember that in a reaction, an element or an atom needs to become stable by gaining or losing electrons. Halogens have 7 electrons in the outer shell, and therefore to become stable, it will need 1 more electron. So each of these halogens is looking at attracting this electron to itself. Again, I've put the arrows in there, double-headed arrows, to show you the distance from the nucleus to the incoming electron or the electron to be gained. Look at it carefully and you can see the size or the distance. Let's use the word distance here. The distance between the positive nucleus and the electron to be gained increases as we go down the group. Because the nucleus overall is positively charged, the incoming electron is attracted by this positively charged nucleus. So the closer the electron to be gained to this positive nucleus, the more attractive its power is. In other words, the more it can attract the electron stronger. So that is what this diagram looks like, and that is what it means. Now what I've done is I've put it in words underneath the diagram for you. I'm going to just read parts of it for you. So the first thing the examiner will look at is you need to tell the examiner that halogens react by gaining 1 electron to their outer shell or energy level. Why? Because they need to gain noble gas electron structure. Noble gas here means they need to become stable. The harder the electron to gain, the less reactive the halogen. Now we go back to the trend again. As we go down the group, the size of the atom increases. You can see that from the diagram here. The size of the atom increases. or the number of shells increases. So you can see fluorine has 2, chlorine 3, bromine 4, iodine 5. So you can see that the size increases or the number of shells increases. Okay. As the size of the atom increases, the outer shell becomes further away from the nucleus. So you can see the outer shell here. I'm talking about the shell close to the X is further away from the nucleus as you move down the group. The force of attraction between the positive nucleus or the nucleus and the outer shell becomes less strong further down the group because the distance is increasing. The distance between the positive nucleus and the electron to be gained is increasing. This makes it harder to gain an electron, and so the outer electron is easily gained. So this explains the trend. Another point is we want to look at displacement reactions in halogen. Displacement reactions in halogens. I've put on here, you can see some diagrams with some test tubes. So you can see 1, 2, 3, 4, 5, 6 test tubes on the left-hand side and on the right-hand side. Now, if you listen carefully to this, it's very important that you listen carefully before I read out anything to you. The 6 test tubes on the left-hand side contain the halogens when nothing has been added to it. So the first 2 test tubes here contains chlorine. The next 2 test tubes contain bromine. And the last 2 test tubes contain iodine, or chlorine water, bromine water, and iodine water. Now what I've done is I've brought the same test tubes to the right-hand side. So again, I've put the labels on there to make it easier for you to know what each test tube contains. So the first 2 test tubes, each contains chlorine water. The middle 2 contains bromine water, and the last 2 contains iodine water. I'm doing this way because we are not in the lab, and I should try and follow what I'm doing. So the first test tube, I add potassium bromide to it. Potassium bromide is a compound. I add it to chlorine. If I move back here, you can see I'm talking about the word yes. Yes means when I add potassium bromide to chlorine, a reaction takes place, and that's why I've put the word yes. What is the reaction that is taking place? The chlorine in the test tube reacts with potassium bromide. So you can look at the equation in the yellow box here. So chlorine in the test tube reacts with the potassium bromide that I have added to it, and that gives us potassium chloride and bromine gas. The reason why this reaction takes place is this. Now look on the right-hand side towards the top, and I've put a reasoning over there. I'll come back to what I was talking about. So in general, a more reactive element can displace a less reactive element from a compound. So if you have a more reactive halogen, then that more reactive halogen can displace a less reactive halogen from an aqueous solution of its salt. Aqueous means something which has been dissolved in water. So if you want to write it down somewhere or look for it later on, aqueous means something which has been dissolved in water. So if you look at it carefully, chlorine is more reactive than bromine, and therefore would displace bromine from the compound. And that is why we have potassium chloride being formed and bromine gas being formed. A yellow solution is formed. If you look in the test tube, the first one, a yellow solution is formed. It's due to the production of bromine. So bromine is what causes this to become yellow. Let's look at the second test tube. It also contains chlorine. Potassium iodide has been added to it. Again, I've put the equation here, and you can see I've put yes, because a reaction will take place. Why do you think a reaction will take place? I'm giving you 10 seconds to just think about it. Thank you. A reaction will take place because chlorine is more reactive than iodine. Chlorine is more reactive than iodine. If I take you back a PowerPoint, you can see what I was talking about. Okay, reactivity decreases down the group, and therefore fluorine is more reactive than chlorine, more reactive than bromine, more reactive than iodine. The same way chlorine is more reactive than bromine and iodine. So that explains it. The third one, potassium chloride being added to bromine water, I said no reaction will take place. The reason is because, if you go back here, the reason is very, very simple. Because bromine in the test tube is less reactive than chlorine and therefore cannot displace chlorine from potassium chloride. The next one, I said yes. Why? Because bromine is more reactive than iodine and therefore will displace iodine from a compound of potassium iodide. I have put the equation here. So when you have potassium iodide reacting with bromine, bromine will displace iodine from potassium iodide because bromine is more reactive than iodine, giving you potassium bromide and iodine. The next test tube, I have iodine in there and I'm adding potassium chloride. Iodine is less reactive than chlorine and therefore will not be able to displace chlorine. So I've put down here, no reaction will take place. Same with the last one, iodine is less reactive than bromine and therefore no reaction will take place. So the only reaction that will take place are the three that I've stipulated here, where the chlorine water or chlorine gas, where the halogen gas is more reactive than the halogen in the compound. Probably you will need to visit or revisit this slide again. Again, it will be live on VLE latest by Monday next week, so you can go back there and read again about it. This PowerPoint I'm not going to go through is the same as what I was explaining here. Again, if you look at the top, I have put for students revision only. So again, I've summarized everything that I was talking about using the test tubes in a table. So if you got the time, just go back to the PowerPoint and have a look at this table. Okay. Right, so we've got 10 minutes for this retrieval practice. 10 minutes. Okay, question 5, there are 6 marks available. So once you've predicted the melting and boiling points, make sure that you explain your answer. So 1 point goes to prediction both melting and boiling points, and 5 marks goes to explaining your answer. Okay, so there are 2 things that you need to do over there. Thank you. You got less than a minute more. Thank you. Thank you. Time up. We'll go straight to the answers. Again, let me just mention here, if you are not able to finish your green pen improvements, don't panic at all. Don't panic. This will be available to you latest by Monday in the live session of the VLE under GCSE. Okay, so you go to GCSE and you find all the year 9 work over there. So answers on the board, you can mark your work. Reactive because they've got 7 electrons in the outer shell, that gives you 1 mark, and it's very easy to gain 1 extra electron or 1 more electron, 1 mark. These are the 2 things that we are looking for. Reactive because they've got 7 electrons and it's easy to gain 1 electron. Diatomic, why? Because they contain 2 atoms. So that is straightforward. 2 atoms, that gives you 1 mark. What will happen if you mix fluorine and sodium chloride? Okay. Talk about the fact that fluorine is more reactive than chlorine, and therefore fluorine will displace chlorine. Meaning how you write it is still correct. Fluorine will displace chlorine. Why? Because fluorine is more reactive than chlorine. Question 4, it says, explain why your teacher would advise you against doing experiments or practical with fluorine in the school laboratory. 2 marks for that. 1, because fluorine is very reactive. Number 2, because it's toxic. So these are the 2 marks. Very reactive because it's toxic. We'll go about 44 seconds to finish our green pen on this page. Okay, we go to question 5. So question 5, you were given a graph, you were asked to predict. That's the first thing you should do. And then the second thing is explain. And I did mention that predict gives you 1 mark and explain gives you 5 marks. If you look at the graph very carefully, I have introduced that for Einstein over there. What did I do? As usual, I usually tell my students, look, if you get this kind of graph, why bother scratching your head? All that you need to do is get a straight edge, a transparent straight edge, or a transparent ruler. Transparent ruler. Put it on there, look at the red line. Okay, so this last bit wasn't on the graph. Okay, I've just put it in there. Put it on there and just draw a straight line with your pencil very lightly on the paper, examination paper. Okay, to start from the edge over there to the edge there. So this bit here wasn't in. Again, this wasn't there. So this bit was there, that was there. So all that I did was to draw a straight line from there to there. And then extrapolate. So I'm just extrapolating this straight line all the way down to the x-axis. From there, I'll be able to get the melting point and boiling point of Einstein time over there. So any number that you give, anything between 270 and 305, okay, will score you a mark for the boiling point. And anything you write between 315 and 340 also scores you your mark for the boiling point. In this particular question, you must get both figures correct to score a mark. So you need to get both of them correct to score a mark. But during this session, if we're able to get one of them correct, that's beautiful. If you got both of them correct, that's even amazing. So the question is, we have predicted, okay? So you predict by drawing this and extrapolating a straight line. And wherever it cuts there, that becomes your boiling and melting point for the one you're looking for. The next bit is to explain. Explain gives you 5 marks. Explain. So number 1, I have put the answer down, but you may have put it in another manner and another way using the keywords that you need to use. So for example, some students will talk about the fact that Einstein time is bigger in size compared to the rest first. Yeah, that's what I'm talking about. So you can put one sentence before the other. I think you'll get a mark. So what I did was very simple, to say that group 7 molecules have intermolecular forces of attraction. The bigger the molecule, the stronger the intermolecular force of attraction. So that one point, another point. Talk about further that particular element is bigger in size compared to the rest. So it means that that molecule will have stronger intermolecular force of attraction. If you write your answer without the word intermolecular, you still get it correct. So some students will write, and that means that Einstein molecules have stronger force of attraction. It still gets you the mark. And if you have strong force of attraction, then that means more energy or a lot of energy. Okay, you can use any synonym to the word more, and you still get the answer correct. You don't just write so energy, that would be wrong. So more energy or a lot of energy or massive amounts of energy, huge amounts of energy, any of this is correct. It's needed to overcome this force of attraction, and that'll give you the full mark. Again, you got about 1 more minute to finish your green pen improvements. Don't rush at all. As I said, if you're not able to finish on time here, it will be available on VLE Live latest by Monday. Thank you for taking part in this lesson.